What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. This is our data visualization with Python tutorial series. Specifically, we are looking at the MatPlotLib library or package in the Python programming language. So essentially what we have done all along is we've only looked at, I would say, the basics of what matplotlib offers us. So like we've went and we've plotted the various kinds of visualizations that we can achieve using matplotlib, things like scatter plots, bar plots, box plots, and so on. It was an interesting journey that we have come along so far, studying the matplotlib package. So like the aim of the next few videos is to get hands-on with the matplotlib, specifically the visualizations that we looked at, and we are going to essentially customize the look, okay, the aesthetics of the plot itself. So we're talking themes, colors, styles, if there's annotations and so on. We will have a look at that. So what I'd like to do in this video, I would first like to, we'll just discuss a bit about what to expect and what we are going to do. And I will provide you guys with the first example, for this video itself. So nothing too difficult. And as always, it is all interesting. So let's get to it. First things first, you'll agree with me, right? We've plotted several visualizations over the past few videos. We've had a look at several different types of ways in which we can visualize a data set or data, right? Now, every one of those plots, they came with their default styles, right? We did not change or mess around with the colors and how it should look. Everything that was shown to us was by default. That was matplotlib just plotting what we gave it and yeah, showing it to us. Colors were not chosen by us. Well, in some cases, we specified color is equals to, and we had a little parameter or argument there, such as R, and we looked at G, and we looked at B. Now, what we are going to do is much more of this, right? Styling. So, as much as matplotlib's default colors serve the purpose of fulfilling the functionality, it is convenient. Okay, having something that's default is convenient, but now in the real world, when we are plotting crucial data or visualizing crucial data, the graph that we have as the result or the finalized or end result of the graph, it should require some sort of deviation from the default style. Okay, maybe we'll need to use some kind of color coding, maybe we'll need a color scheme, just some sort of aesthetics to make the graph much more interpretable to human beings. Now, this is where styling comes into play, right? Having the ability to choose colors and styles and schemes and so on for the visualization allows us to tailor that chart or that plot, for human beings to have a better understanding or interpretation of it. Now, the default colors that we've looked at so far, just presented to us by matplotlib. So let me give you another example. If I run this box plot line of code or cell of code, you'll see that the colors that are given to us is default and it is bland. Okay, now this is where styling comes into play. So I'd first like to mention to you, there are multiple ways to define colors in matplotlib, several ways, okay? And I'd like to just name a few for you. So you get what's called triplets. I spelled that wrong. Triplets. Triplets is basically colors where within a parenthesis, a tuple, we have three values and each value ranges from and can be equals to 0 to 1. So decimals are supported, okay? And essentially what this triplet is, so just to give you a bit of insight, 1.0, 0.0, 0.0. triplets are in the form of a very common color channel, which is known as RGB. Okay, red, green, and blue. That's what the three numbers represent. This is why we call them triplets. This is one way. Now, pay attention, guys, that you can have each number. I will use square brackets because as we learned in math, square brackets means that it is including those numbers. So the values that we use for each triplet, for each channel, red, green, and blue, they can be equals to any value including and between 0 and 1. So this, what we have here as an example, this will give me or give us a bright red color. Okay, and you guys know you can play around with that and alter the color. So if I do, let's say I want red to be 1, so that's full red. I want 0 green, and I want maybe full blue. That will give us a bright pink color. So we have the code from the previous lessons. Let's actually test it out. So let me find a scatter plot maybe. The scatter plot is plt.scatter. That's going to be right on the top. I just want to show you guys. So there's it here. This is the plot in the default form or default color. The numbers will change because we are randomly generating, but let's try out that color parameter that we just learned about. So this time the argument we're passing is a bit more fancier. Instead of doing a plain or bland, R, that would have made it red. Let's make it pink, judging by what we just did. So 1.0, 0.0, 1.0. The RGB color channels, we are passing it in the form of a triplet. And if I do control enter, it is correct. We do get a bright pink color. So that is super interesting. And I can just maximize this for you guys to see. So back to the discussion. So the next important thing that I'd like to mention is what's called quadruplets. Quadruplets are very, very similar to triplets in a sense where within a tuple we have values, just that instead of 3 values, you will pass 4 values. Okay, and it is in the standard form of RGB, so we can do again 1.0, 0.0, 1.0. Now you may ask, what does the fourth number in a quadruplet represent? So the fourth number represents what's known as transparency. Okay, transparency is basically the level of transparency that the dots display. So it is an interesting concept. We will look at it and experiment with it later. You guys can play around with it now if you want. Okay, so you can just test it out on that scatter plot. So again, this fourth value can vary between and including 0 to 1. So we can make it 0.25 and so on. That's good. The next one is something we are familiar with. It is known as predefined names. Predefined names are basically what we use. Do you guys know the R, the B, and the G? Those are 3 that we encountered. Okay, R was actually standing for red, B for blue, G for there's the greater than sign. This was green. Those are not the only 3 predefined names that exist, right? I should mention, you'll have the ability to actually type the color out in full. So you can actually type color is equals to and the name of the color, red. You can type green and so on. The aliases, this one character that we see here, it was kind of built into MatPlotLib by the developers. These are the common colors that we work with, and so they gave a short alias that we can use. Now, just to give you a bit of other aliases you can use, you have R, you have B, you have G. Now you also have C. The color this will give you is cyan. Then you also have an alias for M. The color M will give you is magenta. We have Y, and as you guys probably guessed, this will give us yellow. We also have K. K will give us the color black. And lastly, we have W, which will give us the color white. So those are the predefined names. Now, the next interesting one we have is what's called HTML color strings. So if you are familiar, with HTML and other kind of these concepts, triplets, quadruplets, and so on, then it is good to know that Python, when it comes to Matplotlib, you'll be able to use your HTML color strings as your arguments to the functions, the plotting functions parameters. So that is good to know. HTML color strings. In case you don't know what this is, basically a color string that is commonly defined. Now, I don't want you guys to get confused. There is a hash included in the color strings, okay? This is what a color string looks like. It looks as follows. So you have RRGGBB. Again, these are the most common color channels, the red, green, blue, RGB. And basically, you also may know them as hexadecimal colors. Hexadecimal colors. The color itself is not hexadecimal, but the way in which the color is represented is hexadecimal. So, oftentimes, what I also recommend for you guys is if you search in Google or your search engine of choice, just search, look up, HTML, or my bad, search for hexadecimal color picker. And there'll be this very convenient interface that gives you the, hexadecimal code or color string for the color that you'd like. So it is very handy. Now, that's fine. The next and last one that I'd like to discuss is what's called gray level strings. Gray level strings are nothing really that difficult to understand, but basically all you need to know is that Matplotlib by default, it will interpret a string representation of a floating point value as a shade of gray. Okay, this value ranges between the common values, 0 and 1, and you'll have the ability to also set it equal to 0 and 1. And it's basically, this is a scale between 0 to 1 is the level of grayness of a color. So you'll have the ability to do stuff like that. To give you a bit of insight, if you are wondering, 0.75 basically will give us the color a medium light gray. The closer you are to 1, the greater the intensity of the gray color. So that's good to know. Now, that was quite a bit of talking. Now, what we can do is I'd like to actually proceed to demonstrate. So suppose we are working with a common scatter plot. Let me create a few lines of space here. So a scatter plot, you have several abilities. Okay, first things first, you guys know the scatter plot is plotted using plt dot scatter. This is nothing new to us, we encountered it in the previous video. Now, there are two options to control the color of the dots, using the color parameter, and we will explore them all, as many as we can. So the just to put it into perspective for you, right, you'll have the ability to set a common color for all the dots, which is as we've been doing, right? You guys know the scatter plot we view here is an example of what we just said, a common color for all the dots. Your other alternate option is to have individual color for each dot. Okay, individual color for each dot. Basically, if the color parameter is a sequence of valid matplotlib color definitions, then the ith dot will appear in the ith color. Okay, obviously that will be a lengthy process, right? If you didn't know, it is possible. You can set each dot, literally each dot in your plot, to have a different color, but you will require a really large amount of unique colors if you want each dot to display uniquely. So that was a lot to say. Let's get to it now. Let's get coding. Import numpy as np, import matplotlib dot py plot as plt. The standard importations, you guys are familiar with that. Now I'm just going to generate some dummy data. We'll create a few plots and we'll plot it on the graph itself. So what I'd like to demonstrate first, I don't want to get you guys confused with regards to the gray level strings. I think it would be feasible for us to first demonstrate how this would work. So let's do that. I will set a is equals to numpy dot random dot standard normal. Within this, let's pass 100 by 2 for the shape. This is us using numpy's methods to generate dummy data. Now what we can do, say a is equals to a plus. Let's do numpy dot array. Within this, let's pass -1 to -1. b is equals to numpy dot random dot standard normal. Within this parenthesis, a size, let's pass 100 by 2. Essentially what we are going to do is we are comparing two different scatter plots on the same canvas. Okay, so when plt.scatter is called for both of these curves or these plots, we'll pass a different color in gray color scale to the plots itself. So b is equals to b plus numpy array, and within this, let's say 1 and 1. That's fine. Now plt.scatter, this is the first one, so let's do a, and indexing operations here, or slicing rather. Since we have a two-dimensional array in both instances, let's go ahead and do slicing. So a, I would like all rows of column 0. For the y values, let's plot a, all rows this time of column 1. Now before we pass color parameter, I want you guys to just observe. Notice I'm not passing color parameter for now. So let's just plot, we'll view, and then we can add the color afterwards. So same situation here, guys. Go ahead, slice these arrays, plt.show. Now run your script. I actually capitalized somewhere. Okay, that's fine. Let's do np.array. Okay, run the script and you guys will see there are two plots here. You guys know by default matplotlib is giving us each plot in a unique or different color. Now let us take into consideration what we want the color to actually be. We want it to be in gray level string. So what we will do is, as the name indicates, within a string, any value that ranges between 0 and 1, including the start and stop values. The closer you are to 1, the greater the intensity of the color gray will be noticed. So let's do the plot A first. Say we'd like a light colored gray. What we can do is pass color is equals to 0.25. For the next one, color is equals to 0.75. What we are expecting is the plot for B to display or show signs of a greater intensity of the color gray. Why? Because the gray level string for the plot B is closer to the value of 1, which is basically explaining what we expect. So control enter, and as you guys can see, this is what we have. So it is super interesting stuff, right? And this is just the beginning. Now, is there anything else I'd like to show you guys for this video? Yes, there is. So I'd like to just, introduce you to one more parameter. So we looked at the color parameter, right? Now I would like us to look at what's called edge color. That's a parameter as well for the scatter plot specifically. Okay, we are just tinkering around with the scatter plot for now. So you guys know, right, this scatter plot has dots. Now essentially what I want you guys to think of is that you see color and edge color. Color is the color of the filled dot, and the edge color is the color of the rim of the dot, the circumference of the circle. Okay, the line that actually draws the circle. That's what I want you guys to think of those two parameters as. If it does not make sense, don't stress. I will give us an example now and it will make sense to you. And remember, for now I am doing this in gray level strings for you. You have the ability to really play around with colors as per your preference. Go ahead, change the color parameter here, or the argument, to be equals to, yellow or magenta, or find some hexadecimal colors online and so on. Just go crazy, guys. So just for fun, let's actually experiment here with magenta, and let's do maybe, what's a good color? I think cyan would be a good color. So control enter, and as you guys can see, we have the colors reflecting. So it is interesting. Now edge color. So let's do import numpy as np. Let me actually copy paste this and have this on the clipboard, because we do type that quite a bit, right? So data is equals to numpy.random.standard normal. Within this, the size of our data set, suppose again we'd like a 100 by 2. When we are plotting plt.scatter, essentially what we will do is data will take the first and then the second column. Data colon 0, data colon 1. Now the parameters we are playing around with is, or are, color and edge color. First things first, let's run this without messing with those parameters. Just control enter and we get this plot. Please note, guys, the plot will change because data is being randomly generated. Now let's actually hard code the colors into the system. So let's do color is equals to, let's choose something that's noticeable. So let's make the circle inside, the entire circle should be filled with the color maybe yellow. So I'll pass y. Now if I run this, you guys will see there is a bunch of yellow circles that's showing up on the plot. Now edge color, this is the cool parameter. It really makes each dot stand out. So suppose you'd like to set the edge color to be equal to maybe, I think black. Black will be the most noticeable one. That's K. Control enter, and as you guys can see, the plot has changed in some way. Specifically now talking about the dots or the circles themselves, right? The data points have changed visually. We see a thin black line which is bordering each data point, and this is the effect the edge color parameter has on the data point. So I hope you guys are finding this really interesting. Now, another thing I'd like to do, right? I would like to actually use, as I promised, the gray level strings. Okay, guys, now we will pass color into our plt.scatter function using, the color and the edge color parameters. Now, what's important to note is I may have actually mixed up my words earlier. Please take note now. You guys know the gray level string is depicted by 0 to 1, including both numbers. Now, what's important to understand is that the closer the number is to 0, the greater the intensity of the color gray. Okay, the closer the number is to 0, the greater the intensity of the color gray. I think earlier I mentioned it in a sort of mixed up way, but I am correcting it now. Please take note of this, guys. And the closer the number is to 1, the, let me say, more whiter okay, the more whiter the color is. Now, I'm not too sure how to phrase that, but basically, the aim or the goal of what I'm trying to get at is, you see, let me demonstrate this for you. So we have this plot. That's the plot with the default colors. Now, if I set color is equals to 1.0, I want you guys to pay careful attention to this. Color is equals to 1.0 gives me, it appears as a blank scatter plot, but in reality, this scatter plot is not blank. It's just that, as I mentioned, the closer the number is to 1, in this case, the number is 1, the more whiter the color is. Okay, the more white that is added to the color, which basically lessens or dullens the effect of the color gray. Now, I hope this makes sense to you. Okay, now if we have this intensity of the color white, we should get a color that's in the middle of white and black, which is like pure gray. Now, if we do a number that is closer to 0, the greater the intensity of the color gray, and in actual sense, you guys will see we get the color black. Okay, I hope you are finding this interesting. Now, this is what I want to demonstrate for this specific example. I want the circle itself, the color of the circle, the dot, to be white, and I want the edge color to be black. So essentially what I have to do is just follow this little scheme here. Let me retype this here. Closer to 1.0 is white. Closer to 0.0 is black. Now, what I am asking us for, I want you guys to also code this in your IDE. I want the circle, the color of the dot itself to be white, and I want the edge color, the rim of the dot, to be black. Please pause the video, guys, spend a few seconds, code it, and then you may view the solution as well. So if you have attempted this, essentially I asked for the dot itself to be white and the edge color to be black. So the first thing I would do is make sure that edge color is black. And how would I do this? I would set this equals to 0.0. And if I wanted the dot to be equals to a color of white, I would set it equals to a value of 1.0. Now control enter. And as you guys can see, we get this. That is as expected. Now, I think we will end the video here. Essentially, what we did is we really just looked at and played around with a bit of customization for our scatter plots using the MatPlotLib package in Python. So thanks for watching, guys. Thanks for staying till the end of the video. Do be sure to leave a like if you are learning something new from my channel. Subscribe to the channel for new, technology tutorials. And with that, guys, thanks for your time. Good luck with your work, and I will see you in the next YouTube video.